Hi everybody, this is the review for Unit 1 Exponents test. The directions say to show all of your work for full credit and to box in your final answer. These same directions are going to be on your test, so make sure you're watching how I'm writing and showing my final answers so you do the same on your test. This first section are 4 radical expressions, so we see the radical in all of them, the square root, and we're matching it with this exponential form, with a rational expression. So these half powers are rationals. So the first thing I noticed when I looked at this problem is that A and B are super similar. The only difference is that B has parentheses while A doesn't. So let's review quickly what a rational exponent looks like. So in a rational exponent, I have a numerator, the 1, and I have a denominator, the 2. When I convert this to a radical expression, the numerator of my fraction, this 1, becomes the power. The denominator of my fraction becomes the index. Now, when I write a square root, if I don't see an index there, I assume it's a 2. And same thing with this exponent of a 1. I usually don't write an exponent of a 1. If I don't see an exponent there, I assume it's a 1. So these two things are equivalent right here. If there's no index, if there's no little numbers sitting on top of the radical, I assume it's a 2. If there's no exponent, I assume it's a 1. So applying this concept over here, 10m to the 1/2 and the quantity 10m to the 1/2. In A, only the m is the part that's being raised to a power of 1/2. Only the m. So only the m is going to be under the radical. So that would match with 4. In part B, 10 and m are underneath the radical. So that would be matched with number 2. Now C and D are quite different because there's different numbers under the radical or the rational exponent, and there's a little more going on in these ones. So what this is asking me is, what is the square root of 400m? 400 is actually 20 times 20. So the square root of 400 is 20. I can't really square root m because I don't know what that variable stands for. I don't know what kind of number m is. So there's really nothing I can do with m, but I do know that the square root of 400 is 20 because 400 is 20 times 20. So C is going to match up here with 1. So that leaves number 3 to be D, but I'm going to show you why. So this rational exponent of 1/2 means that I'm going to take the 100m to the 3rd power underneath the radical with an exponent of 1 and an index of 2. 10 times 10 is 100. Oopsies, I forgot the 3 there. The exponent of the 3. 10 times 10 is 100. And then m cubed, we know, means m times m times m. The reason why the square root of 100 is 10 is because 100 is 10 times 10. I can do the same thing with my m's. M cubed is m times m times m. I'm looking for a square root. I'm looking for a pair. So I do have a pair of 10s and a pair of m's. Pair of 10s, pair of m's. And then I have a leftover m that's going to stay underneath the radical. Okay, the directions here say to simplify this fraction completely, to reduce all fractions, and do not leave any negative exponents in my answer. So I'm first going to look at my coefficients, the 25 and the 5. 25 divided by 5 is 5. Now the rule with my negative exponents is that if I'm negative in the numerator, I'm going to move it down into the denominator. And if I'm negative in the denominator, oh, I'm not. This one, negative in the denominator, I'm going to move it up to the numerator. Now, we always don't have a negative in the numerator and the denominator. It doesn't mean that something's switching places, that the f and the g have to change places. That's not what it means. If we have a negative, it needs to move. It doesn't necessarily have to take the place of something else. So again, this g squared is staying, and this f to the first power is staying. What's moving is f to the second power to the negative 2. This is coming down and becoming positive. G to the negative 3 is coming up and is becoming positive. So g squared g to the third becomes g to the fifth. Remember, g squared means g times g, and g to the third means g times g times g, 5 of them. Combining my f's in the denominator, I have 1f, and then I have f squared, which is 2f's. That's going to be f to the third. I've followed the directions. I've reduced my fraction of 25 divided by 5, and I also did not leave any negative exponents. So I'm done. The g and the f, I can't go any further. They're different variables. In number 6, this third power means that I'm going to write out 3bn 3 times. 3bn times 3bn times 3bn. 3 times 3 times 3 is 27. B times B times B is B cubed. N times N times N is also N cubed. Working with my next set of parentheses, I'm squaring this. So I have negative 4b squared n cubed and negative 4b squared n cubed. Negative 4 times negative 4 is positive 16. B squared, that's bb. B squared, bb, so that's b to the fourth. N cubed, that's 6. Now, from the beginning of the problem, we see these parentheses around them. So that means that there's still parentheses and we're still multiplying. 27 times 16. I'm going to do 27 times 10. And I'm going to do 27 times 6. I'm going to add those together. Okay. 432, b to the 7th power, n to the 9th power. Okay, fill in the blanks to completely simplify the following expression. So what I notice when I look at this problem is that 4 times 3 is 12. I'm going to do the same thing in the denominator. 2 times 3 is 6. Again, just like the last problem, t cubed means t, t, t. T squared means t, t. How many t's do I have? 5. Now I'm going to apply division. So 12 divided by 6 is 2. I have t to the 5th in the numerator, and I have t to the 4th in the denominator. T divided by t is 1. So all of these are going to cancel out, or you can use your subtraction rule here, that 5 minus 4 is 1. You all know that you don't need to write to the first power, so my final answer is just 2t. Okay, that's all for this video. Catch the rest in the next video.